My name is Philip Osterbein, and this is my presentation on historical engineering. I'm going to start off with the Age of Antiquity and the Pharos of Alexandria, otherwise known as the Lighthouse of Alexandria. The Pharos of Alexandria was commissioned to be built by Sostratus of Cnidius during the Ptolemaic Kingdom of Egypt. It was constructed between 284 and 246 BC in Alexandria's eastern harbor. It took approximately 33 years to construct. It was constructed primarily with solid blocks of limestone and granite. The lighthouse was made up of 3 tiers, each built separate before being assembled together at the final site. It is estimated to have been at least 330 feet in height, with a 98-foot by 98-foot rectangular base. It is estimated to have cost around 800 talents to build, which would have been around $3 million USD. I think the Pharos of Alexandria is a great example of the civil engineering of the Age of Antiquity. This engineering accomplishment appeals to me because it attempted a feat that would otherwise be thought to be relatively impossible in its time period, but the problem was solved by building it in an unconventional way at the time. Because of this, it is actually one of the 7 ancient wonders of the world. Next up, coming from the medieval period, is the Gutenberg press. The Gutenberg press was invented in 1436 by Johannes Gutenberg, a German goldsmith. He began designing the press with the idea of a machine capable of producing pages of text at an incredible speed. At the time, there was no efficient way to mass-produce text or books, but Gutenberg's invention solved this problem. Gutenberg's press was designed around the traditional screw press with an added matrix on which individual letters and symbols could be arranged. Along with the press, Gutenberg developed a unique oil-based ink, much better than the water-based ink of the time. The Gutenberg press is a great example of early mechanical engineering during the medieval period. It is a researched, designed, and developed tool to better society and thus fits this discipline perfectly. This invention appealed to me for a similar reason that it fits the discipline of mechanical engineering. Johannes Gutenberg saw a problem that needed solving, and he researched and developed a tool to solve it. Next up, coming from the scientific revolution, Pascal's calculator. Invented in 1642, Pascal's calculator was a mechanical calculator invented by Blaise Pascal in 1642 AD. Pascal was inspired to design a calculator after seeing all the laborious calculations done by his father, a supervisor of taxes in Rouen, France. Pascal's calculator was made possible by its carry mechanism, which adds 1 to 9 on one dial and carries 1 to the next dial when the first dial changes from 9 to 0. The machine was designed to add and subtract 2 numbers directly and to perform multiplication and division through repeated addition or subtraction. Pascal's calculator and its following renditions costed about $80,000 USD in today's currency. I believe that Pascal's calculator is an excellent staple in mechanical engineering, as similar to Gutenberg, he saw an opportunity to make a certain problem or job significantly easier and more efficient. He then developed and produced a tool to perform that purpose. Pascal's calculator is an excellent example of the advanced engineering during the scientific revolution. Pascal's calculator appeals to me because not only was it a great example of the principles of engineering, but it is also something that was incredibly innovative and inspired a device that I still use today, a digital calculator. Next up, coming from the Industrial Revolution, is Fitch's The Perseverance. Built in 1787, the Perseverance, a steamboat designed by John Finch, has been accredited as the first functioning steamboat. The first successful trial run of this steamboat was made on the Delaware River on August 22, 1787. Fitch's steamboat used a system of side-mounted oars propelled by a system of levers and pulleys that were driven by a steam engine. The steam engine used in Fitch's invention was inspired by the Watt engine and designed for the Perseverance with the help of Henry Voigt. Fitch's steamboat, as with many of the other examples, is an excellent example of mechanical engineering. This time, it was not a problem being solved, but rather an opportunity being envisioned and brought to fruition. This invention appeals to me because I think that is a very cool example of innovative thought, taking a current technology, e.g. the steam engine, and using it to create a new technology. Now moving on to the second industrial revolution is the 1903 Wright Flyer. Built and first flown in 1903, the 1903 Wright Flyer was the first successful self-propelled airplane, capable of sustained flight. Prior to this, controlled and sustained flight had not yet been achieved. The 1903 Wright Flyer was a simple fabric craft constructed by the Wright brothers, Wilbur and Orville. It was based off of their previous experimental gliders, with an added four-cylinder internal combustion engine propelling the blades. The craft cost the brothers a little less than $1,000 to construct, equivalent to around 28,000 USD today. The 1903 Wright Flyer is a fantastic and innovative example of early aeronautical engineering. The Wright brothers' ability to harness their available technology to develop something that is crucial to society even today makes them some of the most important aeronautical engineers in history. The Wright Flyer appeals to me because I find it vastly impressive and inspiring that their invention sparked so many new possibilities as it was built upon: safer travel, faster shipment, etc., etc. Moving on into the age of information, we have ARPANET. ARPANET was a project born out of a need. The Advanced Research Projects Agency, ARPA, needed a means of enabling access to remote computers. Bob Taylor of ARPA initiated the project in 1966 and appointed Larry Roberts as the program manager. ARPANET was the first wide-area packet switching network, as well as the first network to implement TCP/IP protocol suite, e.g. IP address. It was declared operational in 1971 and enabled multiple firsts: remote login, file transfer, as well as email. ARPANET cost the U.S. government approximately $25 million USD to develop. ARPANET is an excellent example of computer engineering. The development of ARPANET laid the base for the World Wide Web, thus being the groundwork for arguably one of the most important and useful features of computers. The invention of ARPANET appeals to and inspires me because not only is it one of the most important inventions of recent history, but it also aligns with a field of engineering that heavily interests me.